Hello viewers, welcome to today's session. This is Mahesh from Mahith Academy. Today we are going to discuss about the topic transfer function for linear time invariant systems using Laplace transform approach. While going to discuss about this topic, we have to know what are the different types of control systems. Those are linear systems, non-linear systems, continuous systems, discrete systems, time variant systems, time invariant systems, like different types of control systems are there. Why I am going to consider linear time invariant systems only and the transfer function for this linear time invariant system only using Laplace transform approach. There is a reason for considering linear time invariant systems for the transfer function analysis. We know all the systems in the nature are non-linear. There is no linearity in the physical systems. But while we preparing a mathematical model for designing of a system, we will consider the analysis for linear systems and time invariant systems only. If we know the analysis of these linear time invariant systems, it can be absolutely approximated for any kind of system. The mathematical equations for other systems calculations and analysis is also becomes easy while we know the analysis of linear time invariant systems. So that is the reason we will always consider the transfer function for linear time invariant systems only. And also this transfer function analysis for linear time invariant systems utilizes the impulse signals always, because while we observe the concept of impulse input, if we apply the impulse signal at the input side, we will get the impulse response at the output side. So based upon this concept, we will find the transfer function for linear time invariant systems utilizing the impulse input and impulse output. For this analysis, we are going to use the Laplace transform approach. We have different types of approaches for finding the output response and transfer functions for linear time invariant systems for continuous and discrete systems are there. That is time domain analysis, Laplace transform analysis, Fourier transform analysis. In this session, we are going to discuss about the transfer function and the responses for signal and the system for time invariant systems using Laplace transform approach only. If we observe carefully, for a linear time invariant system, when the input x of t is applied or input r of t is applied, for control systems purpose it is reference signal taken as r of t. For signal sense systems it is taken as x of t as the input. There is no difference, both are same only. And the output c of t we will get, or for signal sense systems it may be output y of t. If x of t is the input, output y of t for signal sense systems. If r of t is the input, output c of t for control systems. The transfer function may be g of t, which defines the relationship between input and output variables. That is transfer function variable. So using this transfer function g of t, which is equals to ratio of c of t by r of t, or in signal sense systems we can define this as h of t is the transfer function, which is equals to y of t by x of t. So this is the transfer function for linear time invariant systems. And the relationship between the impulse response and the transfer functions is when we apply input impulse input, we get output, impulse output only. So the transfer function h of t or g of t equals to Laplace transform of output by Laplace transform of input, that is impulse response of any kind of linear time invariant systems. So for any kind of linear time invariant systems, if we know the impulse response, then it is very easy to find the response for any kind of input also. Let us suppose if a step input is there, there is a relationship between step input and impulse input. Differentiation of step is nothing but impulse, or integration of impulse is nothing but step. Like this, utilizing this relationship, the impulse and step responses at the input side will be defined in terms of impulse responses only.